Good morning, pre-algebra. All right, while you are turning to page 500, here is today's joke. What is the definition of a good farmer? The definition of a good farmer is a man outstanding in his field. There it is. All right. Today we're going to be discussing and learning about the topic of negative exponents. So if you look at on page 500, or you can look here on the screen, I took kind of the big idea that helps me understand where negative exponents take us. So when we look at positive exponents, we are increasing. We go from right here, we went from 10 to 100 to 1,000. See how our decimal place is kind of increasing. We keep moving the decimal one place to the right. Well, it's the opposite direction when we talk about negative exponents. First thing, this is really important. This is really important. This is really important. 10, anything with the exponent of 0 is going to equal 1. If the exponent is 0, the answer is 1. So if it's 10 to the 0 power, if it's 5 to the 0 power, it's going to equal 1. You're going to want to remember that. But going on, we have negative 1, so now we have gone to a fraction, 1 over 10, or it would be 0.1 for people like me who kind of need like the visual display. And then see how our decimal is now moving to the left, from this way, moving left instead of to the right. Yeah, there's the arrows, so it makes a little bit more sense. Okay, if you're still not so sure, I want to take you to the next, at the very bottom of your page. This is what really helps me understand about how we write our negative exponents. So here we have 8, x to the third divided by x to the fifth. And so as you learned yesterday, whenever you have division, that means that you are subtracting your exponents. So if we were going to do that, we would write it as x to the negative 2. However, we want to express, which means we can write x to the negative 2 power in a way where our exponent becomes positive. And here is how. So I've taken our problem, x cubed over x to the 5th power, and I've written out all the x's just to kind of make it plain. And so just like we know that we can cancel things out that are the same with division, so we can cancel those, and those. So now that leaves us with just 2 x's on the bottom. And so we write this as 1 over x squared. You notice how there isn't any sort of negative symbol. Well, you're right, it's true, we could write it as this, but the way we would write this expression as a positive exponent is that this is the way. So for the most part, if you have just a simple expression of x cubed, negative 3 cubed, then we can just simply write that as 1 over x cubed. We're just pretty much just putting it underneath as a division problem. That's how we would write a negative number, negative expression, as a positive exponent. So now turn your attention to page 501. You're going to see this process. So for example, here they have 2 to the negative 3rd power. So that means if we want to write it with a positive exponent, we would do 1 over 2 cubed. Okay. What about if I were going to have y to the negative 3rd power? Well, that's going to be 1 over y cubed. And then, here's your other trick, 2 to the 0 power, that's going to equal 1. Alright, remember that one. It's kind of funky. Alright, now let's go on to example number 2. It says, write each fraction as an expression using a negative exponent other than negative 1. So now we're doing the opposite. We're given a expression that has a positive exponent, but we need to turn it into a negative one. So our first example is 1 over 4 squared. All right, so now we just work backwards. We want to take this to have a negative exponent, so we're going to write 4 to the negative 2. Okay? Now here's something that's a little tricky. Not equals. Our next one is 1 over 100. All right? So this is where we actually have to factor our number. We'd factor our number as, well, 10, 10. Oh, and we can stop there because we have a common base. So we can say that we're now dealing with 1 over 10 squared. So with that knowledge, I can then say, oh, this is 10 to the negative 2 power. So look out for numbers. You can see some numbers where you can multiply them by 2 of the same numbers so that you get a squared. That's a very good example. Or let's look at the example 2C where we have 1 over 27. Now there's no two numbers that equal 27. You know, it's not 4 times 4 or 5 times 5 is 25, but 6 times 6 is 36. So we're actually going to kind of have to do our factor tree to figure this out. So I know that it's 3 times 9. 3 is prime, but 9 is not. So I'm going to continue to factor it. Oh! Now I have 1, 2, 3. 3 threes. So I'm going to say this equals 1 over 3 cubed, which if I want to write as a negative exponent, I'm going to have not negative 3, I'm going to have 3 to the negative 3 power. So those are our steps. So some things might be simple, like this one, and some things might take more effort, where you have to write out the factor tree. Don't be afraid to use up room in your notebook. Okay? Alright, moving on down. Let's flip the page and look at our last example, example number 4. It says algebraic expressions with negative exponents. So it says evaluate 4a to the negative 5th power if a equals negative 2. Alright, so I'm going to plug in my information. Now I'm going to have 4 times negative 2 to the negative 5th power. Okay, so I want to write this with a positive exponent. So if I'm going to change this, I'm going to have 4 times 1 over negative 2 to the 5th power. I'm now going to solve what is negative 2 to the 5th power. So that's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. And so these are all negatives. So since I have 5 negatives, I'm going to end up with negative 32. So I'm going to rewrite this as 4 times 1 over negative 32. And the way we can think about this is 4 over 1 times 1 over negative 32. And since we have this multiplication going on, we want to cross simplify. So we can simplify these two numbers. So 4 goes into 32 how many times? 8 times. So that's going to cancel this out. So I'm going to be left with a negative 1 over 8. Okay, so again, the process of changing our negative exponent into a positive exponent, solving that exponent, because we can really only solve it, it makes more sense for us, at least for me, when we have a fraction compared to some odd decimal. And then working out the problem, and then solving from there. Look out for that cross factoring. That's going to be pretty common. Let's do another example for that one, and then we'll finish up. So I'm looking at 4a. We have m to negative 2, and m equals 4. So we have 4 to the negative 2 power, which then equals 1 over 4 squared, which equals 1 over 16. That was pretty simple. Let's look at the next one. We have 6mn. Here we go. 6mn. And n is to the negative 4th power. And we know that, let's see, 4 and 3. So I'm going to just write this out. So we have 6 times 4 times 3. Remember, this is the one being with the negative exponent. So I'm going to have 6 times 4 is 24 times 1 over 3 to the 4th power. So that's 3 times 3, which is 9, times 3, which is 27, times 3, which is 81? Yeah. No. 3 times 3 is 9, times 3 is 27, times 3, yeah, 81. Okay, so we have 24 over 1 times 1 over 81. So we're going to end up with, I don't think that's right. Yeah, no, that's fine. We can divide both by 3. So 81 divided by 3 is 27. And 24 divided by 3 is 8. So we're going to have 8 over 27. Alright, so that we divided both by the number of 3. That's what was going on there. And so this is our final answer of solving our fraction. Okay, I think this stuff is going to be the trickiest. However, if you're still struggling with the idea of a negative exponent, please ask for help. We're at 12.5 minutes. I'm going to say goodbye, and I will see you in real life.